Welcome to another session based on area related to circles. In this session, we are going to discuss about areas of sector and segment of a circle. First, we will derive the formulae for finding the areas and then solve some problems based on these formulae. Do you remember what is a sector of a circle? If I take a circle with center O and radius R and I mark 2 points on the circle A and B, join A and B to O respectively, I get 2 radii, and you can see that these radii are dividing the whole circular region into 2 parts, each called a sector. So how can we define a sector? We can define sector as a region bounded by 2 radii and an arc of a circle. A sector is named by taking a point on its arc. So if I take a point P here, this arc APB is a minor arc, and hence the sector APBO is called a minor sector. Similarly, if I take a point Q on the other part of the circle, AQB is a major arc and the region AOBQ is called the major sector. The minor arc subtends angle AOB at the center, and let us take its measure as theta. So theta is called the central angle or the angle of the minor sector. And what would be the central angle for the major sector? Right, it would be reflex angle theta. How do you find reflex angle? By subtracting theta from 360. Because you can see that the complete angle at the center is of 360 degree. So if we subtract theta from 360, we get the other angle. Apart from these two sectors, there is another type of sector which can be formed in a circle. It is the sector formed by a diameter. If the radii AO and OB form a straight line, then it becomes the diameter of the circle, and the two sectors which are thus formed are called semicircular sectors. In that case, both the angles at the center are of 180 degree. So there are 3 types of sectors in a circle. Now let us talk about the areas of these sectors. If we consider the 360 degree angle at the center, the total area corresponding to this 360 degree is the whole area of the circle, which is pi r square. So area of a sector of angle theta will be theta upon 360 into pi r square by using unitary method. If the minor arc APB has length L, then we can also find the formula for calculating L. The complete length of the circle is 2 pi r, which corresponds to 360 degree central angle. Therefore, L being the arc corresponding to angle theta, its length will be theta upon 360 into 2 pi r. Substituting this value, we can find out another formula for area of a sector. If I multiply and divide this expression by 2, I have half theta upon 360 into 2 pi r into r. Now theta upon 360 into 2 pi r gives us L, and so we have the formula area equal to half LR. We can use this formula if we know the length of the arc corresponding to which we have to find out the area of the sector. Now, once we know this area, we can easily find out the area of the major sector by subtracting the area of minor sector from the whole area of the circle. So, area of major sector will be area of circle minus area of minor sector. These are the formulae related to area of sector. Next comes segment. What is a segment? If you remember, we obtain a segment by drawing a chord of a circle. So let us take a circle with center O and draw a chord AB of this circle. You can see that the whole area of the circle or the circular region is divided into 2 parts. The part which is smaller in size is called minor segment, and the other part is called major segment. Another characteristic which differentiates these segments is that the center O lies in the major segment and it does not lie in the minor segment. The third type of segment which we can get in a circle is semicircular segment, which we obtain when the chord AB is a diameter of the circle. Now to find out the area of a segment, we will relate it to area of a sector. If I join OA and OB, I get the radii and hence a sector of the circle. Marking the point P on the minor sector, just observe how can you find the area of the minor segment APB? Yes, you are correct. We can find this area easily by subtracting the area of triangle AOB from the area of sector APBO. So in order to find the area of segment, we first need to find the area of this triangle. If you are given theta equal to 90 degree, or you know all the three sides of this triangle, you can easily find the area using the formula half base into height or the Heron's formula. If the angle theta is something different, then we have another formula for finding area, which is r square sine theta by 2 cos theta by 2. So area of minor segment is equal to area of minor sector minus area triangle AOB. Now about the major segment. The area of major segment AQB can be easily found by subtracting the area of minor segment from the complete area of the circle. Just to add here, you should also know the formulae of area, circumference and ring of a circle discussed in the first session. So these were the various formulae related to areas. Now let's try to apply these formulae. You may not need to draw the figure in every question, but I am just making this figure for your understanding. Most of the time we can solve the question without a figure also. So in our first problem, radius of the sector is 6 centimeter and the angle of the sector theta is 60 degrees. So area of this sector will be theta upon 360 into pi r square. Replacing the values, 60 upon 360 into 22 upon 7 into 6 into 6. Cancelling and solving further, we get 132 upon 7 or 18.86 centimeters square. In the next problem, we are given a quadrant. Do you know what is the angle of a quadrant? A quadrant is 1/4 of a circle, so its angle is 90 degrees. So theta is equal to 90 degrees. Here r is not given. Instead, we are given the circumference of the circle, which is equal to 2 pi r. So 2 pi r is equal to 22, or 2 into 22 over 7 into r is equal to 22. Therefore, r is 22 into 7 upon 2 into 22. When you shift the numbers to right hand side, numerator becomes denominator and denominator becomes numerator. So finally we get r is equal to 7 by 2 centimeter. As we are not asked r, we can keep it in fraction for our convenience. Area of quadrant will be theta upon 360 into pi r square. That is 90 upon 360 into 22 over 7 into 7 by 2 into 7 by 2. Simplifying, we get 77 upon 8, which is equal to 9.63 centimeters square approximately. If you are finding the answer in decimal, you can just find it correct to 2 decimal places. In the next question, a chord of circle of radius 10 centimeters subtends a right angle at the center. So r is equal to 10 centimeter and theta is equal to 90 degrees. As we have to find the area of segments, we will have to make a figure in this question. So you can see that ACB is the minor segment and its area can be obtained by subtracting the area of triangle AOB from the area of sector ACBO. As AOB is a right triangle, OA and OB are its perpendicular and base. And so the area will be half into base into height. that is half into 10 into 10 equal to 50 centimeters square. If you find it difficult to handle many things at a time, you can separately find the area of the sector and then subtract the two to get the area of the minor segment. I am doing it directly. So area of minor segment is equal to area of minor sector minus area triangle AOB, which is equal to theta upon 360 into pi r square minus 50. As the value of pi is given 3.14 in the question, we will have to use this value only. So 90 upon 360 into 3.14 into 10 into 10 minus 50. So just to remind you here, as there are many calculations, we must follow the BODMAS rule of arithmetic here. So cancelling and multiplying, we get 314 upon 4 minus 50. Taking the LCM and simplifying further, the final answer is 28.5 centimeters square. So got an idea how to find the area of a segment? In the next part of the question, we have to find area of the major sector, and angle of the major sector will be 360 degree minus theta, that is 270 degree. Therefore, area of sector is theta upon 360 into pi r square, that is 270 upon 360 into 3.14 into 10 into 10, which is finally equal to 235.5 centimeters square. Observe that I did not find the area of major sector by subtracting the area of minor sector. We can also use the formula of area of sector for a major sector directly as done here. Now let's try the next problem. Here the radius is 21 centimeter and the angle theta is 60 degree. As we are asked to find the area of a segment, we need to draw a figure also. So let us quickly draw the figure. The arc corresponding to this sector is arc ACB. So length of this arc is equal to theta upon 360 into 2 pi r equal to 60 upon 360 into 2 pi into 22 upon 7 into 21. Cancelling various parts and multiplying the remaining, it is equal to 22 centimeters. The area of this sector is given by theta upon 360 into pi r square, which is 60 upon 360 into 22 over 7 into 21 into 21. Simplifying it, we finally get 231 centimeters square. So you can observe it is just a direct application of the formulae most of the time. In the third part, we are asked to find the area of the segment formed by the corresponding chord. Corresponding chord means the chord formed by joining the endpoints of the radii of the sector, that is the chord AB. So we have to find the area of the segment ACB, for which we first need to find the area of triangle AOB. As theta is 60 degree and OA is equal to OB, the other two angles of the triangle will also be 60 degree. Why? Because they will be equal and the sum of all the angles should be 180. Do you remember the formula for finding area of an equilateral triangle? Right, root 3 upon 4a square, where a is the side of the triangle. So area of triangle AOP is equal to root 3 upon 4 into 21 into 21. That is 441 root 3 upon 4. And therefore the area of the segment is area of sector ACBO minus area triangle AOB, which is equal to 231 minus 441 root 3 upon 4. You may leave the answer here also, but if you are given the value of root 3 in the problem, then you will substitute the value and solve it further. So now I think you can easily solve the next question yourself. Pause your screen and complete it. I'll share the answer sheet, and if you have any problems, you can talk to me in the comment box. Now let's try this one. This one involves finding the area of a segment, so let us draw the figure quickly. Here r is equal to 12 centimeter and theta is 120 degree. As theta is other than 60 or 90 degree, we have to use the formula r square sine theta by 2 cos theta by 2 here. If it's not convenient, you can first find the area of sector and then the area of triangle AOB and then subtract them to get the area of the segment. But I am doing it all together. So area of the segment is area of sector minus area triangle AOB, which is equal to theta upon 360 into pi r square minus r square sine theta by 2 cos theta by 2. We are provided with the values of pi and root 3, so we will be using them in the answer. So substituting all the values, we have 120 upon 360 into 3.14 into 12 into 12 minus 12 into 12 into sine 120 upon 2 cos 120 upon 2. Cancelling various terms in the first part and multiplying, we get 150.72. Sine 60 degree is root 3 by 2 and cos 60 is 1 by 2. So replacing the value of root 3 in the next step and simplifying further, we get 150.72 minus 62.28, which gives area 88.44 centimeters square. Are these steps clear? If you have any doubt, you are welcome to ask me in the comment box. So today we have solved some knowledge-based questions based on these areas where we had to directly apply the formulae. In the next session, we are going to discuss word problems or application-based questions on area of sector and segment. If you want to check out this video, you can click on this link. And don't forget to subscribe, like and share. See you in the next session. Goodbye for now.